Hello, my name is Irene Salinas. I'm a marine science graduate student here at KAUST. My presentation is entitled, What are we fishing? The implementation of AI to tackle data deficient fisheries in the Red Sea. In the last 60 years, our annual fish consumption has more than doubled, rising from 9 to 20 kilograms per capita. This led to an increased exploitation of the oceans, which endangers marine biodiversity and ecosystem balance. Fish are a necessary component of the human food system, especially in coastal and developing countries. What happens is that we don't know what we're fishing out. Fisheries suffer from a knowledge gap. We have no precise information regarding the species being harvested from the sea. This data is essential for designing efficient management strategies. It is known that stocks that are scientifically assessed and managed have a greater and increasing abundance of fish. On the contrary, regions without assessment and little or no management show degraded and declining stocks due to overfishing. The Red Sea is one of these regions. It is one of the most diverse seas in the world, with high rates of unique species, but the main anthropogenic activity that endangers reef systems and organisms here is overfishing. And how do we propose to tackle this problem? With the use of a deep learning artificial intelligence framework, object detection, which is the core task of computer vision. Can we manage to move forward from a fish classification into a species level classification of multiple detections? Well, first we require a large data set. The EVIL lab has the perfect tool to help in this task. The cloud labeling platform they created is meant to provide object detection as a service for scientists from other areas, like me. We don't need to learn to code in order to get the benefits of artificial intelligence. The secret is in collaborating with a team of people that do. With this tool and using our empirical knowledge of fish, we can manage to annotate the thousands of images required to efficiently train a model that allows us to detect and identify fish species out of the water. Once that we trained a model, the ideal next step will be to use the model to identify images recorded by a deployable device. This device ideally will be installed in fishing ports in the Red Sea. We can start with Saudi Arabia. This will allow us to record images of the fish that are put inside and automatically upload them to the cloud. So the trained model can count and ID the fish by species. This technological innovation will allow us to efficiently analyze the outstream of fish from the Red Sea. This system has the potential to be deployed in other parts of the world, but for that, we require to annotate a larger set of species to consider different regions. This is doable. We just need to collaborate with more people and teams from other universities. The tool and technologies like AI are out there. We just need to implement them in creative ways. The collection of this species, the collection of this fish data will allow us to design a strategic ecosystem-based fisheries management in the Red Sea that will have positive long-term impacts. A well-managed fishery informed by science can increase its productivity, bring economic benefits, and ensure a sustainable use of the sea. Thank you.